We're just going to pick up from where we left off. How hard does it get, actually? I'm trying to think. I mean, the diagrams are looking pretty interesting. It's not that bad, is it? No, it's not that bad. I mean, if you understand when two triangles are the same, then you're set. Like, look at this. We already know these two triangles are similar, right?
Mm-hmm.
It's because they both have a 90 degree, like angle B is equals to angle D. They're both 90 degrees. And we know that angle BCA from the left triangle, this angle, is equals to angle ECD from the right here, because they are opposite angles, right? Opposite angles are equal. So therefore, triangle ABC is similar, look at that symbol, similar to triangle CDE. This is always what you're going to be doing. If you want an A+, you need to show that they are similar. And if you don't write this thing, you might get points deducted, right? Like, how do you know those are the same? So make sure to specify how you know those angles are the same as well. All right, so that's the easy part. They're similar, right? What's next?
Mm-hmm.
We're trying to find
You
x.
you find the scale factor.
Okay, what over what?
30/18.
30/18 is right. So that's 6 goes into 35 times. 6 goes into 18 3 times. So the scale factor is 5/3. Okay. So they're asking us to find x, which is the side AB. And we know AB is the side DE times the scale factor. Yeah.
Mm-hmm.
Well, this 15 is DE times the scale factor is 5/3. 3 goes into 15 5 times. Therefore, x is 25 meters. And if you want to really get the good student bonus point, you want to say the bay, therefore the bay is 25 meters wide. And there you go. Pretty straightforward, right?
Mm-hmm.
This is the exact same question. Look at this. They're super lazy with the diagram as well. This diagram here in question 5 and this diagram here, nothing changed, only the numbers. They've only changed the numbers up. You can just do this in our heads really quickly. Explain why DEC is similar to ABC. How do you know they're similar?
They both have two similar angles.
Yeah, so they both have the right angles there, and at C they have opposite angles which are equal. What ratio might this individual use to determine the scale factor? What over what gives you the scale factor?
740/37.
What is that? Quick maths. 37, 20 exactly. 74 is 37 times 2, so this is 20. Therefore, AB, the distance across, is going to be 26 times 20, 520. The exact same question as question 5 here, word for word. This one looks to be a little bit different. And if they don't give you, that's the fun part. If they do not give you a diagram, that question is going to be a little bit more difficult than the rest. So what do we know here? We have a ladder that's 3.6 meters across, like over here. And let's say this is the wall here. Wall is always assumed to be at a 90 degrees. So there you go. This is the setup. This is your ladder, the hypotenuse. And A to B is your base. And B to C is the wall. Okay, draw a scale diagram. All right, let's assume this is the scale diagram. But when you actually do it on a graph paper or something, you want to do like 2 meters, right? So 1 box, 2 boxes, 2 meters. And 3.6 meters ladder. So you want to go across like 3.6, which is going to be a little bit tricky. You're gonna do this with a ruler, and then when they join, right, like here and here, you just draw a straight line across, and that's gonna be the height of the ladder. Okay. Suppose that a 2.4 meter ladder is placed against the wall parallel to this ladder. If we need something to be parallel to this, it must be going this way, right?
Mm-hmm.
3.6 and this 2.4 meter ladder are parallel. Explain why the triangles formed are similar. How can we show that these two are similar?
They have the same angles.
Okay, B is good. What's the other one? They both have the 90. Which other angles is the same?
A and O.
Yeah. So therefore, those two triangles are similar. C. How far up the wall will each ladder reach? So we know this distance here was 2 meters for the bigger ladder. Okay.
Mm-hmm.
And the question is, what's this distance, CB? And what's the other distance, EB? What's our approach?
Pythagoras theorem.
Yep, Pythagoras theorem would help us with CB, right?
Mm-hmm.
So CB is just gonna be 3.6 squared minus 2 squared. So square root of 3.6 squared minus 2 squared, that's going to be 2.99. Right? How do we find EB?
You
Yeah,
find the scale factor.
okay, whatever, what gives you the scale factor?
3.6 over 2.4.
Quick maths, what is that? They're both 12 goes into both of them. Or 1.2 goes into both of them. 3,
1.5.
yeah, exactly. 1.5 is their scale factor. Therefore, EB times the scale factor gives you CB. Smaller guy times the scale factor gives you the bigger guy. Therefore, EB is going to be CB 2.99 divided by 1.5. It's going to be approximately 2. Because this is 3, right? 3 over 1.5 is 2. And you were done. Cool?
Mm-hmm.
Similar triangles, not very difficult. I don't even know what's going on in this diagram. Let's pull this one up. It's a lot of wordings there. So it wants us to find the height of the pole. So I'm assuming it like all this distance it wants us to find. Alrighty, what's our approach? You don't even need this wordings actually. They've already given you the diagram. So we're gonna find the height of the pole. What would we do first?
You could use
Well, first you want to prove that they are similar.
mm-hmm.
They both have 75. They both have a right angle. That means they are similar triangles, right? Prove that they're similar, step 1. Then what? We need to find the scale factor.
So 5/3?
Yeah, the scale factor is 5/3. Now if you label this, you can say A, B, C, D, E, right?
Mm-hmm.
We know that BD divided by the whole pole is BD. BD divided by CD, right? The hypotenuse, not the hypotenuse, the height of both the triangles. We know that is going to be the scale factor, yeah?
Mm-hmm.
Let's assume that the distance from C to D is X. Like this. So that means what's BD in terms of X? What is BD in terms of X? Because we need to turn this into an equation.
X plus 7.46.
Yeah, exactly. X plus 7.46. That's BD. CD is just simply X, and that's equals to your K value, which was the scale factor, 5/3, like that. How do we solve this equation for X?
You multiply by X.
Yeah, that one's pretty simple. Multiply by X. And then
Subtract 7.46.
okay. Then what? You need to bring the like terms on the same side. So by that, if you have multiple numbers, bring them on the same side. If you have multiple x's, bring them on the same side. Instead of subtracting 7.46 here, what you should do is leave the 7.46 where it is, subtract x. Common denominator between 3 and an invisible 1 is a 3. So you'd multiply this by 3 up top, 3 on the bottom. So you'd get 2x over 3 is 7.46. Therefore, x is 7.46 times 3 divided by 2, whatever that is. Okay,
Mm-hmm.
cool.
Yep.
What is this question asking us? Determine the height of the hill. Okay, they've given us everything. I don't know why they made the diagram, but they made it. Okay, we're gonna assume that they're similar because this angle is the same for both of them and they both have a 90, so they are for sure similar. We want to find h. This question is tricky because there's three triangles in here. There's the smallest one with the blue, and then there's the red one in the middle with the 1.6, and then there's the H one, the big one. So there's actually 3 different triangles. All of them are going to be similar, right? Because they all have this angle here, and they are all like 90 degrees. So all 3 of the triangles are similar, right?
Mm-hmm.
Okay, what do we do? Any ideas whatsoever? We've proved that they're similar. The next step would be to find the scale factor. What if we make this distance again? See, it's gonna get more and more complicated. That's the beauty of this. We're gonna make this distance x from here to here. right? Let's say we have A, B, C, D, E. We can say this is F, this is G. Again, the letters are arbitrary. It's not that big of a deal. If you look at the smaller two triangles, the scale factor, because there's going to be two different scale factors. Scale factor is going to be 1.6 over 1. The scale factor is 1.6, yeah? If you do this distance divided by this distance, you can find what x is, right? In other words, if you do AF, you see AF, okay, we're looking at the smaller two triangles, divided by AG, this side length, AG, that must be the scale factor, yeah? What is AF in terms of x?
X plus 12.
Yeah. What is AG in terms of x? Remember, x was the distance from here to here, right? So AG in terms of x is just simply an x. Okay? This is going to be equals to 1.6. So to solve for this, multiply both sides by x and then subtract x from both sides. Going to end up with this. So you get 12 divided by 0.6, which we know is going to be 20. So x is 20. So again, we're going to clean this up. This distance is 20 from here to here. Yeah? So that means this entire distance across is going to be 20 plus 12 plus 415. So what is that? 427, 447 meters all the way across. We know the distance from here to here is 20. Therefore, your second scale factor is going to be 447 divided by 20. Yeah? 447 divided by 20, that's going to be 22.35. And we know this over this, the scale factor is going to be exactly the same because we just compared this, the base with the base, the height must be the same. Therefore, h divided by 1 must be the scale factor, yeah? So h divided by 1 is the scale factor, so 22.35. Therefore, the height of whatever that is, hill, is 22.35 meters. So there we go. This one, we had 3 different triangles. And if you don't put this as x and to find the scale factor here, you can't do this. Sometimes they can say this is 12 and then you need to make this as x basically. If you find one scale factor, you're good because everything else is just going to be smooth from there. Again, to recap for this question, you need to first find the scale factor between the biggest triangle and any of the 2 other triangles. Here we found the base by using the first 2 small triangles, and then we found the scale factor for the bigger picture, and then we found the height. That one was pretty tricky. This one is super easy. Look at this. Again, opposite angles, right angles, they're similar. The scale factor is 10, right? 0.5 to 5, that means 1/6. This window is 16 meters because the scale factor is 10. One and done, easy. It says find the length. This question right now is unsolvable because there is no way to get the scale factor. See that? Here they've given you the hypotenuse, but here they've given you the height of the triangle. Even though the two triangles are similar, we can see the angles are the same, then they both have a 90 degree. With just this information given, it's impossible to determine x and y. To find x and y, they would need to give us the hypotenuse here, this side. Because using this and this 3.4, we can find the scale factor, yeah?
Mm-hmm.
Right now, as is, it's unsolvable. So if they gave us AC, we can do this question by using Pythagoras theorem and special triangle properties. This question is also very similar. So AB is 96, AC, the hypotenuse is 204, and BD, oh, interesting. Maybe this is gonna be a pull-up question. BD is 396. That means here all the way to here. That's BD. That is 396. All the way to here. Just calculate the width of the river. Width of the river would be DE. We know that these two triangles are similar, right? I'm not going to do it every single time, but if you see it on a test or an assignment, you're going to first show that angle C is the same for both opposite angles, and B and D are right angles. So they're similar, okay?
Mm-hmm.
Just make sure to show that they're similar triangles. Alrighty. What do we do here? I'll give you a hint. There is a way for you to find what BC is. Using that 396, you can
Do
find
you divide
CD.
by 2?
Say that again?
Do you divide by 2?
No, you don't. You don't know if it's a midpoint or anything like that. Think, how can we find BC? In fact, you don't even need that 396 to find BC. Look at the type of a triangle it is.
Oh, you use Pythagoras theorem.
Yeah, exactly. You're going to use Pythagoras theorem. That's going to give you BC. Again, we don't need to show every steps here because we're a little bit beyond that. But it's going to be 204 squared minus 96 squared, square root of that. BC using Pythagoras gives us 180. Okay, 180 here. That means the CD is going to be 396 minus 180. 216, yeah. So it wasn't divided by 2, and it rarely is in these questions. If it was equal, then they would probably tell you that like this or this, something like that. But here we had no inclination that it was 2 divided by 2. From here, it's easy, right? So the scale factor K is going to be 216 over 180. Therefore, DE is going to be AB times the scale factor. Always, the bigger guy is always going to be the smaller guy times the scale factor. So it's going to be 96 times 216 over 180. And what does that give? So this is 115.2. And you're done. So yeah, this was a Pythagoras theorem question. Here's one more. Oof. This one is a trick question. Do you know how areas are related when it comes to the scale factor? We talked about this once or twice. Here, we're going to prove this. Let's say you have some triangle 3, 4, 5, okay? And then you have another triangle. We're just going to double it, 6, 8, and again, Pythagorean triples. It's going to be 10. What's the scale factor?
2?
Yeah, exactly, it's 2. Now check this out. The area of the bigger one is not going to be the area of the smaller one times 2. So this is something that you're going to have to know. The area here is gonna be 4 times 3 divided by 2. It's a what? 12 over 2, 6. The area here is gonna be 8 times 6 divided by 2. That is 24. You see that?
Mm-hmm.
So this is a very important thing that they don't usually tell you. When it comes to scale factors using areas, okay, area big times area big is the small area times k, not only k squared. Because we know the scale factor is 2, but if you compare these two, it's 4 times as big, right? In other words, it's k squared. Cool.
Mm-hmm.
Area big is area small times k squared, not just k. Side lengths are going to be k, but these guys are going to be k squared. So using this idea, we're going to solve this problem. So area big is 324. Area small is 142.56. And we multiply that by k squared to find the scale factor. So divide both sides by 142.56 and you square root this guy. The scale factor k is like 1.5. Okay.
Mm-hmm.
The dimensions of the photo and the frame are proportional. So we did part A. Part B, determine the width of the frame. Okay, one key idea here, square frame. And it doesn't always have to be a triangle. Like in this case, it's not a triangle. So we know this guy had an area of 324, right?
Mm-hmm.
It's a square. How do you find the side length?
Square root.
Yeah, square root of 324, and it's a nice number, 18. The smaller frame had an area of 142.56, right?
Mm-hmm.
I mean, let's square root this and we're going to see if we did it right. If you square root this, you get like 11.94. But we know using the scale factor is 1.5. If we divide 18 by 1.5, we should get approximately the same thing. 18 divided by 1.5 is approximately the same thing. It's 12. So yeah, we've done it right. Okay.
Mm-hmm.
So area big and area small, when it comes to scale factor, it's k squared, not just a k. Most of these questions are super simple. You just do this over this. That's going to give you the scale factor. And then you're going to divide 7 by k to get x, 6.8 by k to get y. It's pointless, most of these questions. Gonna try and do something that maybe we haven't done. If they give you a diagram, it's very simple. You just find the k. Not always, but for the most part, it works. A right triangle is a Pythagorean triple 6, 8, 10. 6, 8, 10, because 36 plus 64 is 110 squared. The longer side of a similar triangle, which side in a triangle is the longest?
The hypotenuse.
Right, so this is 15. Okay, what's the scale factor?
3.
It's not 3.
Oh,
What is it?
1.5.
Yeah. So this one here is going to be 8 times 1.5. So 8 plus 4, 12. This one will be 6 plus times 1.5. It's going to be 9. It says find the area of the larger triangle. You can either do 12 times 9 divided by 2. Or if you want to use the scale factor approach, you can do 8 times 6 divided by 2. times 1.5 squared, and they will both be exactly the same. So this person put a mirror on the ground 5 meters from the base of a flagpole. So let's say this is the flag. 5 meters away here, we have a mirror on the ground. So the mirror is somewhere here. She stepped back until she could see, okay, and then she stepped back. She could see the top of the flagpole reflected in the mirror. Connie's eyes are 1.5 meters above the ground, and she saw the thing when she was 1. Oh my God, there's a lot happening in this question. The distance from here to here is 1.25. The question is, how tall is the flagpole? So what happened was, she's up here. She looks into this mirror that's on the ground, yeah?
Mm-hmm.
And she sees a reflection of the flagpole like that. Not perfectly drawn, but these two, I'm pretty sure, are opposite angles. They're supposed to be the same. And there's a right angle here, there's a right angle here. So they are also similar triangles. So the tricky part here is drawing the diagram itself. How do you find the height of the flagpole? They're similar triangles. They have the opposite angles and they also have a right angle.
You find K.
Yep. What's K in this case?
It's 4.
Yep. So that means your H is going to be 1.5 times 4. It's going to be 6. So the flagpole is 6 meters tall, and you are done. There's this one. Cam is designing, yada, yada, yada. The flag will be triangular with sides. Is it a right angled? Doesn't look like it. Is it though? Let me just double check. 0.8 squared plus 1 squared. The square root of this is the square root of this 1.2. No, it's not. So this is not a right angle triangle. So we can say this is 1.2. We can say this is 0.8, and we can say this is 1. Cam has created another triangle that measures. Now look at this. The smallest here needs to be the smallest here. This needs to be 20. The biggest here needs to be the biggest. That 1.2 is going to end up becoming 30, and that 1 is end up going to becoming 25. So the scale factor is 25. See that? 25 divided by 1. And now we're going to see if 20 divided by 0.8 is 25. Yes, it is. So this also checks out. 30 divided by 25 is 1.2. So this is another way to show that the angles, the triangles are similar. If they don't give you any of the angles, the K value for all 3 sides have to be the same. In this case, the K for all 3 sides is 25, 25, 25. Therefore, the triangles are similar. Therefore, the scale diagram is good. Okay?
Mm-hmm.
So they're not always going to give you angles. Keep that in mind. If they give you, yeah, show that 2 of them are equal, then you got a similar triangle. If they don't give you any angles, like in this case, you have to show that all 3 Ks are the same. Okay, these ones are pretty whatever. Let's try doing this real life problem. This would be a application type problem. Okay, so there's a road somewhere that rises 8 meters over a run of 120. So they've basically given you rise over run, yeah?
Mm-hmm.
This is 8, 120. 8 rise, run is 120. What's the slope? How do you find the slope? Slope is simply rise over run, yeah?
Mm-hmm.
Slope is rise over run. It's simply 8 over 120. What is the rise over run? That means what's the slope? This is the m value, okay? Slope is mx plus b, m. The second part here says, what is the rise over run of 50 meters? So that they've given you the run if the slope remains constant. So rise is missing, run is given 50 meters, and slope is constant, so slope is still 8 over 120. We know rise over run is the slope, so this is going to become a very simple equation. Rise we don't know, we know run is 50, we know slope is 8 over 120. How do we solve for rise? You want to do something on both sides.
Multiply by 50.
Mm. So 8 divided by that over that is 3.33 meters. So rise is 3.33 meters. That's part A. Part B says, well, why are the slopes the same? Well, they're the same because they're similar triangles. Because the other one, we have a rise of 3.33 and the base is 50 meters, right? Like that.
Mm-hmm.
And the slope is going to be the same because one angle is the same right there and they both have the same angle there as well. So because they're similar, the slopes are going to be exactly the same. This question is interesting. A moving truck has 2 ramps. One of them is 3 meters long and one of them is 4 meters long. Which ramp creates a greater angle of elevation with the ground? All right, let's say this is where it loads and unloads, yeah? Let's say this is the truck. Notice how this distance is going to be the same regardless, okay? The distance from the truck to wherever it's loading and unloading is going to be the same, okay? The only thing that's going to change, the base is going to be the same. The only thing that's going to change is the ramp. The ramp is the hypotenuse. So you have a ramp that is 3 meters and you have a ramp that's 4 meters. See that? Which one has a higher slope?
The second one.
The more vertical it is, the higher its slope. If it's a straight line, what's its slope? What if it was like this? What's the slope of a straight line, vertical line?
0.
Horizontal line is 0. Remember the calculus, the tangent line, the horizontal line, there's 0. Vertical line is infinite. That's why when we go to write an equation of a vertical line, there's no m on it. It's going to be x equals whatever the x-intercept. Anyways, here, this one has a higher slope. That means angle of elevation is the same thing. Angle of elevation is the angle at which this thing is with the ground. If you compare them, this angle is way bigger because 90 is here than this one. This looks like it's like 30. This looks like it's like 40 plus. And we're back to doing SOHCAHTOA's which kind of builds upon from, I guess, similar triangles. What do you think about SOHCAHTOA?
It's okay.
It's okay. It's not that difficult.
No.
Okay, what's our plan of attack here? We want to find that theta there, which is the angle, right? Can use anything you want to. Remember, if angle is missing, it's gonna be an inverse question. Here we can really quickly find out what x is because, I don't know, it says x. We're just gonna find x. It's gonna be 5.39 squared minus 2 squared and a square root of that. X is 5 meters or centimeters, whatever this is, centimeters. Any ideas on how to find theta? Remember, you have to do an inverse question. So this is like a trick question where the angle is missing, so we're gonna have to do inverse.
You could do 2 divided by 5.39 and then sine inverse.
Yeah, that's gonna work. So it's gonna be, the thing is if you know all 3 sides of a triangle, you can use anything. You can do sine inverse of opposite over hypotenuse. The answer to this, whatever angle you get, that's gonna be the same thing as cos inverse of 5 over 5.39 adjacent over the hypotenuse. Or you can do tan inverse of opposite over the adjacent. All 3 of these are gonna give you the exact same angle theta. So theta would be, you can do any one of them. It's like, I'm in radians. Why am I in radians? Degrees. Yeah, it's gonna be like 22 degrees, 21.8. And you're done. Okay? You can use any one of them if you know all 3 sides. You're constrained sometimes if you don't know what the missing side is. But again, if it's a right angle triangle, you can just really quickly use Pythagoras theorem to find out what it is. This is pretty straightforward, I think. You can ignore this. So they want the height of that silo. Okay, this one, notice you can't use Pythagoras theorem because to use that, you need to know 2 side lengths. Here we only have the hypotenuse, right? Relative to that angle of 35 degrees, yeah? What's 18 meters? Is it the opposite? Is it the hypotenuse? Is it the adjacent?
The hypotenuse.
Right, so we know hypotenuse is 18 meters. What about h? Is that the opposite, the adjacent? What is it?
The opposite.
Yeah, so opposite is missing, hypotenuse is given. SOHCAHTOA, this is gonna be a sign question, okay? So, because we're looking for O and H is missing and angles given. So it's gonna be sine 35 equals to what over what?
Opposite over 18.
Right, so it's gonna be the opposite divided by 18. You simply multiply both sides by 18. So 18 times sine 35. Therefore, the height of this is 10.32 meters. And you are done, okay? What you can do to quickly double check if you did it right is that there's no way this height is gonna be longer than the hypotenuse. So if you get a 19 or something here, then that means something may have gone wrong. Most of these are pretty simple. This question, they have not given us a diagram. You can get two different angles when you're talking about these types of questions. You can either get the angle of elevation. Okay, this is the elevation. It's always going to be from the horizontal line. Or you can get the angle of depression here. This angle down here is the angle of something called depression. Why is this important? Look at this. You see this angle here? Is that our angle of depression? Notice it always has to be from the horizontal, right?
Mm-hmm.
This is not from the horizontal. This would be our angle of depression, 60, not 30, okay? This is important because sometimes they don't give you a diagram and they will give you the angle of elevation or depression. Make sure to do it from the horizontal. There are some things you do from the vertical, which you may have done in physics. Maybe not yet. Something called Snell's law. That one requires you to use the vertical angles. But here, angle of elevation depression is always from the horizontal line. Alrighty, he's flying a kite and he has released 25 meters of string. Okay, 25 meters of string. Is that the height of the triangle, or is it the hypotenuse? Is it the base? Remember, he's flying a kite. We know this guy is here. The sister is 80 meters away, and he's flying the kite from here. Is 25 meters the hypotenuse of this triangle, or is it the height of the triangle?
The hypotenuse.
Right, because he's flying the kite this way. So this is going to be 25. The kite, if you remember the diamond shapes from yesterday, looks like this, right? The one good thing about the kite is that their diagonals, they meet at 90 degree here. Every angle there in the middle is 90. They're asking us to find the angle of elevation of the string. So is it this angle here up here, or is it this angle down here? Angle of elevation.
It's A.
Yeah, it's A. Right, the up there, that's nothing. That's not even the angle of depression. The angle of depression would be here. So relative to A, which side is 8? The adjacent, the opposite, the hypotenuse.
Adjacent.
Right, so we have the adjacent, we have the hypotenuse. If you wanted to, you could find opposite using Pythagoras theorem, but that's a waste of time. Which one uses A and H? SOHCAHTOA, sine, cos, or tan?
Cos.
Exactly. So you're going to set this up like this. Cos theta is going to be adjacent over the hypotenuse. Theta is going to be cos inverse of 8 divided by 25. So cos inverse of 8 divided by 25. The answer is 1 meters. Okay?
Uh-huh.
And that's it for this question. Actually, I didn't do cos inverse. Let me redo that. Cos inverse of 8 divided by 25. We're trying to find the angle. No, I didn't press inverse. So this one is 71 degrees. Cos inverse. Because there's no way that angle is 1 degree. I knew that was wrong instantly, because an angle of 1 degree is going to be extremely steep like that. Solve triangle ABC. So we have A here, that's 90 degrees, right?
Mm-hmm.
Small a is usually, okay, it's usually BC. It's the opposite of where the big A is. Big A is here, small a must be up here. If big C is up there, then small c, the side length must be down here. And it says solve. That means you need to find the remaining sides and the remaining angles. So there's 3 things to solve for. How do we find CA? It's a right angle triangle. They have given you 2 sides.
You use Pythagoras theorem.
Yep, it's gonna be 7.8 squared minus 5.2 squared, the square root of this guy. You get 5.81. Okay, how do you solve for theta 2? You can use any 2 sides, right? Because you have everything. And check this out. You can do sine inverse of 5.81 over 7.8 for theta 2, this guy. Or you can do cos inverse of 5.2 divided by 7.8. Or you can do tan inverse of 5.81 divided by 5.2. Right? Opposite over the adjacent. Opposite over hypotenuse, adjacent over hypotenuse. All 3 of these will give you exactly the same answer. What am I going to use? I'm going to use cosine. You can use anything. 5.2 divided by 7.8. That angle there is 48 degrees. How do we find angle C up there? What's the quickest way to do that?
It's 52.
Yeah. It's 42. Good try. Because it needs to add up to 90. This and this needs to add up to 90. If it was 52, it would add up to 100. So it must be 42. And you're done. Easy peasy, right? What does T stand for? It's thermometer, okay?
No, it's not.
It's not. T is for thinking. Solve for INJ. This question is a little bit complicated. For sure. Probably going to be the last question for the day. You see that 8, right? Is it exactly in the middle? We
I
don't know
guess so.
that. It looks like it, but we don't know that because if it was, they would have told us something like this. Alrighty? It may not be in the middle. But notice how I and J, right? I and J, they're the same lengths. What type of a triangle is this?
Isosceles.
Right. What's special about isosceles triangles? Two sides are the same. That means 2 base angles also must be exactly the same. If the other one is 60, this one is 60. Okay? And up here we have 30, and up here we have 30. Make sense? Now what? If the entire thing is 8, let's say this is x. See this? Okay. Then this would be 8 minus x. Do you agree? So let's look at the right one, this one. We want J. I'm gonna attack J. J and this, because that's the two sides we're interested in. We're interested in the opposite, and we're interested in the hypotenuse, right?
Mm-hmm.
This is I. So sine opposite over hypotenuse. Sine 60 is J divided by I. Sine 60, if you plug this in a calculator, the value is √3/2. That is the ratio between J and I. So that means J is √3/2 times I. Now let's go into the other triangle. Using this triangle, right? We do the same thing. Actually, maybe I should have used, we need to incorporate x actually, so we can't use sine. Otherwise, we don't have enough information to do this. I and I is the same, right?
Mm-hmm.
We're going to use I and we're going to use our x's. So that means adjacent. It's going to be cosine. Cosine 60 is going to be equals to, for the right triangle, it's x. For the other triangle, it's going to be 8 minus x over the hypotenuse, like that, you see?
Mm-hmm.
Cos 60 is 0.5. So 0.5 is x over I. 0.5 is 8 minus x over I. Multiply both sides by I. X is 0.5 I. 8 minus x is 0.5 I. Yeah?
Mm-hmm.
That means, again, you can either solve for I or you can solve for x. It doesn't really matter. I is going to be x over 0.5. It's going to be 2x. I is going to be 8 minus x over 2. We know i's are the same. So that means 2x is 8 minus x over 2. 4x is 8 minus x. 5x is 8. X is 8 over 5. Plug this in here. I is going to be 2 times 8 over 5, 16 over 5. And you are done. Cool?
Mm-hmm.
So basically, you have to incorporate in this question, you have to incorporate this side and this side because we know they're the same. And somehow the 8 in here with the x's. That's the only way to do this. If you do it with I and j, there's just not enough information. That's why. And we can call it a day there for today.
Okay, thank you.
See ya.